So we've talked about the algebraic part of linear functions, namely how to find the algebraic description of a linear function, of a function that describes a straight line graph. And we've talked about the components of that and what it means when the problem occurs in context with actual units. So the last piece of the puzzle is to make sure that we see the connection between the functional way of talking about linear functions and the graphical way of talking about linear functions. So in this problem, for example, we are starting off with a graph and then trying to find the algebraic formula for the linear function. But if you recall what we did in section 2.1, this should be easier because from a picture, we actually have lots of points on the line. And remember, we found in section 2.1 that as soon as we can determine the slope, for which we only need 2 points, and we know any 1 point, then we can write down the equation. So, so we could just do the same thing here. I've marked 3 points that have nice coordinates. There's no reason to use, to have to estimate the coordinates in between if we have so many that hit right on the whole number of points. I will point out that when you have a picture of the line, then you can kind of think of slope in terms of its actual meaning you think of slope as being rise over run. And so if you're starting with a picture, you can literally see the rise over the run. For every 3 units this goes over, slope rises 1 unit. And so if you think of slope as the ratio of how far you rise per unit that you run over to the right, then your rise over run here should be 1/3. And you can check that by just picking any 2 points that you can read off of this thing. So there's 2 points. So if you do the regular old change in y over change in x calculation, you should get 1/3. The equation then of this line, we can write this in point slope form very easily because we have the slope. And I know I should do x minus something plus something. And we just mark my somethings here. So I need a value here, I need a value here. Those should come from the x and y coordinates of a point that I'm given. And so here's a y coordinate of a point, and here's the x coordinate of a point. The reason I use that point is because the other 2 that I marked had some negative coordinates, and if I have a choice, I would rather use values that are positive or 0, just because it makes it easier to form my equation. But you can use any of the points, and you'll get the same equation. So in this case, I would get y equals 1/3 times x minus 4 plus 0. And so this would be a perfectly good way of expressing the equation of the line. And so then I might write this as a function and say f of x is 1/3 x minus 4 to use my functional notation. If you did want this to be in what's called slope-intercept form, then you would just multiply out the right side. That's all you ever have to do, is just do the distributive property on the right-hand side. So this would be the slope-intercept form for the same thing. So either of these is perfectly fine for an answer. The bottom one has a name called slope-intercept form. The reason it's called that, by the way, I think everybody knows this, but the slope is the number in front of the x, and then the number here is the y-intercept. So the name slope-intercept form is not all that specific. We need to know this is the y-intercept, or what's called the vertical intercept. It means the vertical intercept would be at the point 0, negative 4/3. The first coordinate of a y-intercept is always 0, because that's just what it means to be on the vertical axis. So right here would be that point. We'd call that the y-intercept or the vertical intercept because that's where the graph is crossing the vertical axis. If you wanted to give a name to the other one, you would call the other one over here, we've already marked, the x-intercept, or you could call it the horizontal intercept. That would be this point here. So we have both the x-intercept and the y-intercept, and we learned in section 1.1 that the intercepts are just the points on the graph that have one coordinate or the other equal to 0. And we know how to find both kinds of things. From a graph, it's too easy. You just drop a dot and read the graph. But we've seen how to do that algebraically as well.